Okay, briefly, without going into much detail, if we got vectors v1 and v2 as given, and a vector v as given, they look like this, okay? The vector 2v1, well, that's v1 plus v1, so it's this blue vector. The vector negative v2, well, that's equal and opposite to v2, so there's negative v2. So here is 2v2 minus v1. This is called a linear combination of v2 and v1 because it's a sum of multiples. It's 2 times v1 added to negative 1 times v2. This is how you add vectors. That's what the geometry of the situation looks like. Now we want to know if we can add multiples of v1 and v2 to get vector v. And by thinking about what it means to have a multiple of v1, we see that it could be any vector along this line, and a multiple of v2 could be any vector along this line. And of course we can move vectors around. We can move them head to tail in order to add them. So if we want to add a multiple of v1 to a multiple of v2 to get v, if you think about it, the multiple of v2 is going to have to end up head to head with v. So we simply draw a vector from the line of v1 up to the head of the vector v. Okay, initial point on the line of v1, the head matching the head at the same point, the arrow at the same point as the arrow of v. And that's what our multiple of v2 is going to look like, and our multiple of v1 is just going to be from the origin up to here. So this is a multiple of v1, this is a multiple of v2, and they add up, head to tail, they add up to the vector v. Okay, so we don't know what the multiple is. We call this multiple c1 v1, c1 being the number we multiply, c2 v2 for this vector, and we estimate, okay? This is c1 v1 for some c1, and looking at the length of this one and the length of this one, it looks like this one might be about 4/10 as long as this one, so we estimate c1 is 4/10. For c2 v2, if this picture is accurate, well, this vector looks like it's pretty much half of v2, so we're going to estimate that c2 is 0.5. So we're doing 0.5 of v2 here, 0.4 of v2 is our c1, v1 is our c1 v1 here. Okay, again, c1 v1 plus c2 v2 is actually your general linear combination of v1 and v2. Any sum of multiples of a set of vectors is a linear combination of that set. So, and v1 and v2 should really have arrows under them. Okay, so we have the equation c1 v1 plus c2 v2 equals v. That's what we're trying to find. Now we're going to solve and see what c1 and c2 would really need to be for the two vectors that we're given. So we substitute 3, 2 for v1, because that's what v1 is. v2 is negative 1, 4. We substitute that for v2, and substitute the 1, 3 for v. And we get this equation. We multiply c1 times this vector, we get this. We multiply c2 by this vector, we get this. 1, 3 is 1, 3. We add these two, and we get what you see here. I'm not going to read it to you, it's obvious. And this translates into the equation 3c1 minus c2 equals 1, 2c1 plus 4c2 equals 3. So there's an equation, a system of equations that we can solve for c1 and c2 using whatever method you want. Okay? Alternatively, we could go from this to this, because this can be written as a matrix equation. This matrix times c1, c2 gives you this. And that's going to be equal to your 1, 3. And that equation is easily solved if you can do the inverse matrix. c1, c2 will be the inverse matrix times 1, 3. Another alternative, if you don't like to solve the system, and it's really kind of easier to write it down as an augmented matrix and solve it, so we've done that too. We've written it as an augmented matrix. So we know that this can be solved, we know that this can be solved, and we know that this can be solved. So we didn't go through the details of solving them, although I did kind of scratch out a reduction of this matrix. And when I did, I found that C1 was 1/2 and C2 is 1/2. That's a solution to the system, that's a solution to the matrix equation, and that's a solution that you get from reducing the augmented matrix. So our estimate 0.4 and 0.5 is pretty close, but it should have been 0.5 and 0.5. And I'll point out somebody did say they wanted that to be 0.5. I said, no, that's shorter than half of V1, call it 0.4. Okay, so that's the process of determining the linear combination that adds up to a given vector.